Hello, everyone. My name is Ian Wen, and I'm the product manager at Promochrome Technologies. For the past 5 years, Promochrome has been actively involved in automating PFAS extraction across a range of methods and matrices. We appreciate SciEx giving us this opportunity to share our results and experience. In PFAS analysis that requires low detection limits, the workflow would typically involve solid phase extraction, SPE, to concentrate and clean up the sample. Depending on the method, the extracted fraction may undergo further evaporation and reconstitution before it is analyzed. While the operator can walk away during the evaporation and analysis stages, manual SP remains a bottleneck as it requires constant supervision to meet PFAS method requirements of flow control and bottle rinsing. It takes 1 to 3 hours of manual attendance per PFAS extraction, depending on sample volume. By automating the SP procedure, this stage can also benefit from walk-away operation. Not only can the staff work on other tasks, the extraction procedure and completion time are always repeatable. The SPE03 is a fully automated extractor that runs 8 samples in parallel and performs automatic bottle rinsing. It has helped more than 100 PFAS labs over the world to extract water, tissue, and soil matrices. To keep the presentation concise, I will just be covering EPA methods 537.1, 533, and 1633 today. Automation features will be brought up as we discuss the results. Now let's dive into EPA method 537.1. I would like to thank the Orange County Water District for sharing their data. Being one of the early adopters, they brought on the SPE03 back in 2019 for method 537.1 and are now also using it for method 533. The extractions are performed using Phenomenex SDBL cartridge, and analysis is done with SciEx 6500 Plus Q-Trap. Space is often a scarcity in labs, making it difficult to accommodate large equipment. Shown here is 2 of the original manifold setups at the Orange County Water District. Fortunately, the compact design of the SPE03s allowed for a simple drop-in replacement. The SPE03 on its own is only 35 centimeters by 35 centimeters. So how do we automate 8 samples in such a small footprint? Well, unlike conventional design that involves multiple valves and pumps per sample channel, the SPE03 achieves the loading of 8 samples using just 1 multi-channel valve and 2 sets of syringe pumps. This drastically reduces the complexity and size of our systems while offering high extraction efficiency. This design also keeps the tubing minimal, making it unnecessary to prime the lines and easy to clean. Now, looking at initial validation results, the minimum reporting level MRL was determined by extracting 7 2 nanogram per liter lab spikes on the SPE03 over the span of 3 days. Shown by the blue bars, average recoveries at this low level were between 92% to 112%. The orange lines represent the prediction interval of result, PIR, which were between 70% to 128%. These were nowhere near the method limits of 50% to 150%, so the lab could confidently go with 2 nanograms per liter as their MRL. The background requirement for this method is 1/3 of the MRL, which comes to 0.67 nanograms per liter, as shown by the dotted line. The plot shows the average lab reagent blank LRB measurements across 19 field extractions. All 19 LRBs on the SPE03 had undetectable levels, while there was a small trace of PFTDA and PFTRDA on one of the manual extractions. Undetectable would be in the noise range of much less than 0.1 nanograms per liter for this lab. Now, with SciEx triple quads achieving PPQ detection limits, we may soon get an even more precise look at these levels. The clean background of the SPE03 is achieved through the minimal Teflon option, which is applied to all our PFAS systems. The PTFE lines are replaced by a non-fluorinated material, and our original Teflon valve rotors have been replaced with PEEK. To look at overall recoveries during routine extractions, here's plotting the 50 ppt LFBs from 19 field extraction batches between the manifold and SPE03. The bars represent recoveries, whereas the lines at the bottom represent relative standard deviation. As you can see, Both manual and SPE03 extractions yielded similar results that are within 70% to 130%. The RSDs are also comparable and mostly under 10%. Keep in mind, these were performed on different days by possibly different lab personnel. Next up is EPA method 533. The field extraction data for 533 were collected from Alpha Analytical. They have also been very generous to share with us results on the SPE03 and vacuum manifold. The work was performed using Phenomenex wax cartridges and SciEx 4500 triple quad. Again, we'll compare the manual and SPE03 analyte recoveries from 8 LFBs across different extractions. Given that method limits are 70% to 130%, as shown by the dotted lines, the recoveries are very tight across the board for both systems. While this is the case at Alpha, we find method 533 to be more of a challenge for labs doing manifold extraction. Using weak anion exchange in this method works for a wider range of PFAS compounds, but requires slower and meticulous flow control, which is tough when extracting multiple samples simultaneously. Well, to achieve uniform flow rates across all samples, the SPE03 uses positive pressure syringe pumps. Unlike a shared vacuum source, these pumps have individual syringes per channel that achieve accurate flow despite variations in the samples and cartridges. This ensures strict adherence to the extraction protocol and constant extraction times. Using a syringe pump, the liquid only flows with each pump stroke, which also eliminates the concern of sorbent material drying out. Like all PFAS methods, 533 requires multiple bottle rinsing steps to recover compounds that stick to the sample bottles. The SPE03 comes with a bottle rinsing option that shoots a jet of solvent into the bottles and shakes them to distribute the rinse. Here's a clip demonstrating how that works. So with uniform flow rates and thorough bottle rinsing, we expect optimal recoveries using the automated system. Now, how does the labeled recoveries change with real samples? Since method 533 uses isotope dilution, we can compare the labeled compound recoveries of the same 8 LFBs with 24 field samples extracted on the SPE03. If you look at the light blue bars, some compounds are on average more affected than others in the field samples. Most noticeable is that the response of the 3 fluorotelomere sulfonates were enhanced, with the 42FTS isotope on the left having the most significant increase of about 35% overall. This is quite common for samples with more complex matrices, which has to do with the ionization of these compounds. You will see something similar in my next section on EPA method 1633. Draft method 1633 is written for the full range of samples that utilize SPE. The Maryland Department of Health, who is participating in the multi-lab validation, performed initial validation on both the SPE03 and vacuum manifold. As a disclaimer, their work is strictly research-based and does not constitute endorsement of any particular commercial product. We also have some field extraction results from Claros Technologies, which is an advanced materials company in Minnesota that specializes in both PFAS remediation and testing. Both labs are now ISO certified for EPA method 1633. Since EPA method 1633 includes 500 ml and 1 liter samples, we also have a top-down bottle rinsing configuration for these larger bottles. Here's another video using glass bottles to demonstrate the rinse. Hopefully this is visible to you. The spray hits the top part of the bottles in all directions and flushes the walls. Starting with Maryland Department of Health, here's comparing the low-level lab spikes extracted on the SPE03 versus manual systems. 4 samples were extracted for each, and the analyte concentrations range from 0.2 to 5 ppt. Across the board for all 40 analytes, the SPE03 recoveries were between 77% to 154%, whereas the manual recoveries were between 61% to 224%. Since method 1633 is still under review, the recovery limits are not set in stone. The wider range on the manual extraction was mainly attributed to the much higher 6.2 FTS recovery. The high 6.2 FTS recovery from manual extraction could be due to random contamination, as we're dealing with low levels here. Looking at the relative standard deviations, 6-2 FTS variation is indeed quite high for manual extraction, standing at 125%. Overall, the RSD of SPE03 was under 21.2%, whereas the manual extraction was under 34.4% for the remaining compounds. Again, since method 1633 also uses isotope dilution, here are the corresponding labeled compound recoveries, which show a similar trend between the SPE03 and manual extraction. Most of these isotopes have greater than 70% recovery. The exception are those with longer retention time, which tend to experience lower recoveries on both systems. This also includes the neutral sulfonamides and sulfonamido ethanols, which are known to be challenging. In fact, the most recent draft 3 of this method widened their limits after considering results from other labs. Now let's move on to some field sample results from Claros Technologies. Claros has exclusively been using the SPE03 to minimize manual work. They shared with us results from 8 extractions, which include 8 QC samples and 40 field samples. Phenomenex wax cartridges were used during these extractions. As a PFAS remediation company, they test many influent and effluent wastewater samples, which can contain high levels of particulates. The picture here shows the colors of the SPE cartridges after a typical extraction. The one on the very left is their QC, while the other discolored ones are from field samples. To alleviate SPE cartridge clogging and abrasion of moving parts, Claros performs their extractions using our inline filters. These are connected below the sample bottles during extraction. Being inline means that all samples pass through these filters as they're being extracted. When it comes to sample bottle rinsing steps, solvents are sprayed into sample bottles and also drawn back through the inline filters to recover any trapped analytes. This anti-clogging approach is similar to packing glass wool in SPE cartridges, where they serve to filter the samples and are washed by solvents to maintain good recovery. Using inline filters, Claros achieved the following labeled compound recoveries across the 8 QC samples. The compounds range between 58% to 134% and follow a similar pattern as what we saw at the Maryland Department of Health. To help visualize, here's a comparison with the previously shown data from Maryland, which were obtained without the use of inline filters. On both sets of data, there were slight drops in recovery for the sulfonamides and sulfonamido ethanols. The overall pattern is similar and did not show a deterioration of performance using the inline filters. So how would these labeled compounds behave in field samples where matrix effects come into play? Out of the 40 field samples, I've grabbed 2 of the more extreme cases to demonstrate variations that one might see. The light blue bars on the left are still the QC recoveries from the last slide. Field samples 1 and 2 are shown by orange and red bars. Both samples exhibit a noticeable dip in the late eluders. These compounds are more absorbent, so we expect them to be more stuck to the sample particulates and more challenging to recover. Sample 2 saw an enhancement of the fluorotelomere sulfonates, similar to what we discussed earlier with field samples running on method 533. In some cases, these can go well above 200%. Sample 1, however, did not exhibit the same phenomenon, so keep in mind there will be variations depending on the nature of your samples. It was also interesting that there was somehow no Gen X recovery in sample 1. This compound is not on the extreme end of either retention time or acid strength, so if anyone has insights, that would be more than welcome. So this wraps up my presentation, which covers validation and field sample results for 537.1, 533, and 1633. If you're also interested in soil or ISO 21675, feel free to watch our more comprehensive presentation on YouTube. In summary, to address your PFAS extraction needs, the SPE03 features a compact design, uniform flow control, and automatic bottle rinsing. With the help of inline filters, the system can also handle samples with particulates.